Hey, good morning. Lesson 16.2 today. I'm on guided practice, page 370. So guided practice is a little complicated today. I always remember this one from class, so did my best to explain this one to you. So number one reads, a lion can run 4 times as fast as a squirrel. So I charted this information. So what I did here on the x-axis, which is the bottom on which I talked about last video, I have the speed of the squirrel, 1, 2, 3, 4, 5, 6, 7, all the way through 12. Now with the lion, I didn't write 1 all the way to 32, but you can see I go 4, 8, 12, 16, 28, 20, 24, 28, 32. So you want to make sure that you do even increments if you do that. You can't just go like, oh, 0, 16, 18, 20, 19, 34. You have to be even with it. So you have to count by certain numbers. Okay. So I imagine the graph for number one, or for the now it says number one says, what would point 3, 12 represent? Now if you remember, x comes first, so here's 3, 12, 3, 12. So what that means, point 3, 12 within parentheses, a lion runs 12 miles per hour. And if they're going at the same rate that they can with their bodies burning the most energy, a squirrel would be going 3 miles per hour. So that is the relationship for number one. Now, number two says list 2 other ordered pairs that show this relationship. I went above and beyond. I wrote 3. We have 1, 4, 2, 8, 3, 12, 4, 16. Remember, it's lion is 4 times as fast as a squirrel. 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. 4 times 4 is 16. Those ordered pairs show the relationship. Number 3, how would you set up the axes to graph exercise 1? Well, I did that. The x-axis and the y-axis. Y always goes up, x goes across, so that's your answer. Number 3. Then number 4, how can you determine the information from a graph for a point that is not shown on the graph? Extend the line to include the points in the question. This line can keep going. So I'd have 5 and 20, 6 and 24, as long as it's times 4, that equals that number.